Hello, everybody. This is Sanjay. Hopefully, you could hear me. My name is Sanjay Kumar. I'm the CEO and co-founder of Blue Sky Statistics. Today, I will chair this session, which is session number 23, Web Frameworks for R. And I'm quite excited. I have four esteemed speakers. They're going to take us through an exciting and interesting discussion on the topic of web frameworks for R. And like you, I'm also looking forward to learning from their presentations. And so a very warm welcome to all of you. Thanks for your time in joining us. I'm sure some of you have joined from different parts of the world. This is truly a global event. One of our speakers joined from New Zealand in a pretty early there. So thanks, everybody. Looks like John also just joined. Hey, John. So with that, let me call my first speaker, Matthias, to kick off this session. Matthias, please take it away.
Awesome. Thank you. I appreciate it. Let me go ahead and share my screen. All right, here we go. Can just someone confirm that this is shared? Can we see it?
Yes, it said hi, Matthias. Yeah, that's the slide.
Great, awesome, cool. Yeah, let me just do a super quick introduction since I probably don't know many of you. Name is Matthias. Been working in marketing analytics for quite a while. I also teach statistical A/B testing at the Nashville Software School, and I'm in upstate New York. But that's enough about me. So let's kind of jump in right away and just take a quick detour into what we're actually going to talk about today, which is sort of like our workaround to try to figure out how we can really kind of utilize or make actionable data out of a whole abundance of data. So I work at a global market tech company. We collect a myriad of data, different data from different platforms. We do reporting, dashboarding, sales data, website tracking, behavioral data, and that treasure trove of data is first, obviously, a fantastic thing to have as a data scientist. But we've also noticed that there's an overabundance of data that can happen where that actually becomes a problem of its own. So we, in the past, have used several BI solutions to try to conquer that. But with that, there comes a ton of problem that could actually hamper growth and productivity. So, for example, there's cognitive overload. So dashboard fatigue is the real thing. If you serve too many dashboards to someone, tend to not look at it. It's not scalable. Secondly, business intelligence can actually be very hard to digest, and it's sometimes tough for non-technical audiences, which specifically I, from a marketing background or working with a marketing team, am challenged with. Lastly, there is sophisticated business intelligence available, but generally requires stakeholders to be self-driven. So number one, you're required to train folks in it. And then number two, you require someone to actually go actively search for this information and then utilize it. I'm sure there's actually more examples, but let's leave it at this for the time being. So really, if we want to figure out a way to democratize data across an organization like ours, where we have marketing stakeholders or non-technical stakeholders, we actually need to find a more digestible way of serving insights. So we've actually tried to figure out how can we serve insights to people on a more individualized basis. At Campaign Monitor, we are using a Slack bot for that. Now, if I saw people, and I only unfortunately see the speakers, but if I saw this as a group and I asked for a show of hands, I'm sure that there's actually a good amount of folks on this call that use Slack in their daily work. If not, maybe you're using Microsoft Teams or some of those solutions. So this is a fairly interchangeable solution. So this would also work with applications outside of Slack. It's just what we're using. This is actually a huge opportunity for us because Slack is at my organization like the de facto communication and collaboration tool, which means that work already happens in like a centralized location. So we can use that using the Slack bot. So let me take a quick detour and talk about Slack bots. So for those of you who are not familiar with the concept of a bot, in layman's terms, it just basically acts as any kind of other user on the platform, but really is a robot that can execute tasks that they're programmed to do. For instance, where if you look at this example here, we could code a Slack bot that just listens to the conversations inside of Slack. And then anytime someone asks for the time, the bot could automatically post a response that then kind of just shoots out the date and time. Quite frankly, this is obviously a very simple use of a bot. Actually don't really know if that's a good use of someone's time to program that. But it kind of gives you an idea of what they do. There's generally two types of bots when it comes to Slack. There's interactive and non-interactive bots. So interactive or interactivity, as the name so would suggest, is something where a user has active interaction with that bot. Like on the previous slide, there's things like slash commands that you can use and other ways to actually have a user put information towards the bot. And then there's non-interactive bots, which is those that just essentially post information into a specific channel or a specific group. For this presentation, I'm just going to focus on the latter kind, the non-interactive ones, since we're trying to figure out how we can post user information or data points directly into Slack. That is not to say that we couldn't make this interactive, but for the purpose of this, let's keep it non-interactive. So at Campaign Monitor, we created the Slack bot called Mr. Predicto, which is essentially configured to take incoming webhooks. So you go through and authorize it with your Slack credentials, and then you're basically provided a unique webhook, which is a link, and I'll talk about this in 1 second, that you can use to shoot information to that you can then automatically configure in some way. So if you're not familiar with webhooks, they're a really, really easy way to interactively or to interact with this, this interface. So in the most basic form, all I need is this webhook, which is a URL. So you see that in here. That is provided to me by the Slack API. And then a sort of message that I can that I formatted as a JSON object payload that I can use to send a request to this specific webhook. So in this case, all I'm saying, hey, I'm sending this hello world JSON payload to this specific webhook, and as I do this, in Slack, it would post this information. Now, in R, there's a fantastic package that's called Hatter, which lets you do this straight out of the R interface. Obviously, the code here looks a little bit different, but hoping it does look a bit more familiar, actually, for those of you that don't spend their days in the terminal. So the post request function from the Hatter package actually just takes the same types of arguments. So there's a webhook URL, which would be that URL that I showed earlier. And then there is a JSON payload that's kind of wrapped up a little bit into like a pasted together function. But really it kind of just does the same thing. So you have the webhook and you have the payload. That in itself, if you were to execute this code, you'll get a HTTP response. If you're familiar with like SEO or something like that, you might be familiar with other status codes. 200 in this case just is the HTTP response code for OK. So this seems like it posted right. And in Slack, you would have the bot post hello world. Now, if we actually, again, from a perspective of what is useful to an end user, this Hello World example obviously is not. So one of the really great resources that Slack has is this block kit builder, which on the website helps you kind of build this JSON payload up as you want to. So as you kind of visually build your message, it actually tells you here on the right side what the JSON payload would be. There is, and this is the really cool thing, which ultimately I wanted to end up with, virtually endless possibilities. So whatever you can write in R, you can push into a webhook via Slack. So we've done things like building internal notification systems. We've built things like paid search, forecasting, anomaly detection, any kind of like visualizations you want to give to an end user in Slack, you can push that out. We've done organization-wide notifications, things like notifying our marketing channel when the marketing monthly console report had been posted, anything like that. So in short, anything that you can envision in R, you can push to Slack in some way using this process. So for example, this is an anomaly detection. This is one that's actually currently still in production. In the interest of time, I know I'm like pretty much, I think 13-ish minutes in. I'm not going to talk about the entire thing here, but basically this is a process that runs and takes data from a data warehouse, analyzes it in certain ways, and then pushes into a channel. If I were to look a little bit closer under the hood here, it would still work the same way. So you would basically just decouple this message. There's a message title that gets put into this JSON webhook. There is a body footer, a body message body that, in this case, I apologize, uses a for loop, but essentially just loops through some data and posts that in there. And then lastly, there's a footer. All of this basically just gets concatenated. You can see it here. There is the message title, footer, body that just kind of gets stored into this JSON object that we're trying to push. So you have the title here, the footer, and the body. As you run this, the response would push that right into Slack. Last but not least, I do want to show that this is also possible to incorporate imagery. So in this case, for example, a simple ggplot visualization could also be pushed at the same time as a different part of that JSON object payload. In the final step, we use a process. For the most part, we have our data stored in a Redshift. We use RStudio Connect to kind of schedule these processes. This is a process that works well in our Markdown with RStudio Connect, but it could be written in an R script file and be Dockerized and be executed that way as well. It's also something that you could write in Python. The same process would work as well. And then we use that or we use webhooks to shoot that into Slack. In our Markdown, it kind of looks like this inside of RStudio Connect, where the same thing is just scheduled out and then runs every day. In this case, around, I guess, lunchtime. In summary, this is a great organizational win because really for both non-technical and technical users, we're able to reduce the amount of business intelligence we need that person to consume. But instead, we can be very precise into what each person actually needs and serve that insight to them directly. And then also from the analytics side, so in terms of my team's time, we're really able to utilize everyone's time a lot more efficiently, where we can automate a lot of those things away, just have code do all the heavy lifting, and then really kind of be able to focus more of our time on things to build stuff that's actually useful to the company. That concludes I know our race started through, but obviously this is just a 15-minute talk. I'll end it here, but I'm happy to double click on anything if there's any questions. Yeah, I'm looking forward to keep talking about this. And I'll end my screen here.
Excellent. So I thank you so much, Matthias. That's pretty insightful, given the popularity of Slack. So that's an excellent integration, pushing out the analytical insights. So let me see, is there any other Q&A has come for you? Nothing so far, but we'll collect them as it comes through. So with that, Casper, who has joined us from the wee hours of New Zealand, thank you so much for that. Please take it away. We cannot hear you. Anybody else has any problem hearing Casper?
Yeah, I can't hear you either, Casper.
We could see your screen, but we can't hear you. All right, Casper is fixing his technical. Now we can hear you. So I think what we can do, Casper, if you do not mind, while you are looking at the microphone issues, so let me go to John. John, will that be okay for you?
Sure, fine by me. If you can hear me and I don't have any problems.
Yeah, no, we could hear you well. So if you could start sharing, then we could at least get back on track once Casper figures out that he's having difficulty. The microphone is automatically switching to mute mode. So that's pretty strange.
Sure.
All right, John. So thank you so much. Take it away.
Which one do I want? This is what I want. I trust you can see my screen.
Yes.
Lovely. All right, so I'm here to talk to you about Ambiorix, which is a web framework for R inspired by Express.js. Let me put that full screen. Take a look at the time so I know. Yeah. So a bit about me, I'm a software engineer. I'm the founder of OPFX, which is a small company that I run here from Switzerland. You can head to opfx.org if you have any questions and if you want more information. We sponsored the event, so hopefully you've seen the logo somewhere. If you want the slides, the link is here at the bottom. And so a quick introduction. First, you can get the R package from CRAN, install it however you want. You can get the development version from GitHub, of course. And essentially, this is the crux of it, I think, probably the most important slide. And the most important slide I have is essentially what I mean by inspired by Express.js is I have, if you know a bit about Express.js, it's a web framework for Node, the JavaScript server-side thing. And you can see the code for the hello world of Express.js here on the right and Ambiorix here on the left, even though they're completely different programming languages. I'd argue they look similar, which was my aim. And so if you run this from RStudio, for instance, this is what you'll get. So it'll open in your viewer, very much like a Shiny application. Before I go further, and because I've had the question asked before, MBRX does not use Express.js at all. What I use is a HTTP-UV, the web, which is the web server built by RStudio and used by Shiny. So I use the same web server, but slightly differently to build a different framework, and it's not using any JavaScript. It's all in R. One difference you will have with probably the most prominent web framework out here for R, Shiny, is that it's an opinionated, or at least less. Shiny is meant to build single-page applications, often referred to as SPAs. Nothing wrong with that, but MBRX is, in that sense, does not put that restriction on you. Though it's probably better to build multi-page applications, which we kind of refer to as traditional. So the traditional website in which you have different pages that you navigate through. It's also not with batteries included, a bit like Shiny is. So in terms of things that you might think of as inputs, doesn't bring you Bootstrap, none of that stuff. Which can be a good or a bad thing depending on how you see things. So the basics of how we would go about building a web application with MBRX. Well, you load the library, very easy, and then you have this MBRX object, an R6 class. There are many of them across the application, across the package, sorry. From MBRX, you instantiate your application, in a sense. And then there you route your handle specific routes that you're interested in. So here, for instance, at the top, we have the home page, which is going to be the first slash. When people visit that, they're only going to see using MBRX. But then we can allow users to visit /about, which is our about page, and there we send something different. You can handle all sorts of such methods with get, post, delete, put, patch. All of them are in there, but you likely use get and post most of the time. And what do I mean by handlers? Those handlers that we pass there, these are functions that take essentially two arguments, just like in Express.js. One, the request, and second, the response. The request, I don't detail too much here. It's very straightforward. Technically, it's an R6 class, and you could put methods on it. It's like this so that it's easily extendable for users. But technically, it's just a list, or it's used as a list that contains plenty of information about, well, the request that is being made to the server. So headers, cookies, stuff like that. You'll find it in this object. And then the response is what you use to send something back, as is there here on line 2. We send something. So that's probably the one you'll work the most with if you use MBRX. And for the response, I've shown you how you send back HTML, which is, well, how you do probably a traditional website, but you can do tons of stuff. CSV, text, binary. You have JSON if you want to build the APIs. You can even redirect. I have an example of that later. All sorts of stuff you can send back as a response. You're not limited to just HTML. However, admittedly, HTML is what you'll do quite a bit with websites. And all the examples that I've shown you so far are quite simplistic. We just send back hello world or something like this. But if you want to build a substantial website, you're going to need a lot more HTML to send back. And writing that as strings in R is atrocious. So we have this render method that allows you to render HTML on the fly. And the idea with this is that then you can use data to render the HTML differently. So for example, here we could use the same template here for all our pages, but we have this title here. We use this specific tag here, title, that will then be rendered as about page. And we can reuse this in different places, just replacing title. And there's another one, which is this tag here with the exclamation marks, and that's essentially to include HTML files. You would likely use a CSS framework, font or some icons and things like that. You don't want to have to copy paste and source files everywhere manually. Instead, you can have header, maybe footer, things like that, and source them in there. You can have as many as you want. That's entirely up to you. But it makes building websites a lot easier. Then a WebSocket, which is that bidirectional communication that Shiny uses a lot, is also available. So here, essentially the WebSocket is what you use for the inputs in Shiny, for instance. So you send a specific message here that would be the name of the input, for instance. Here I receive it and I can react on it. I just print the message that is being received and I sent one back that is being handled somewhere else. That's all JavaScript. And there is, optionally, you don't have to use it, but a convenience little Ambiorix JavaScript library to handle the WebSocket, but that's entirely optional, of course. Then there are parameters which allow you to build dynamic URLs. So for example, you have, like I have on the screen there, you have a list of books. You don't know what categories of books you're going to have in your database at the time you write the code. You just want to make sure you can handle them so that people can go to /books/ whatever category they want, fiction, horror, I don't know what else there is, and retrieve, I don't know, the list of respective books. And you can do this by denoting it with a colon like this. And what Ambiorix will do is parse everything nicely when it comes in, when the path comes in. And you can get it here. Here is a simplistic example where we just return that as an HTML tag, but likely it's something you use to fetch something from a database, etc. And then we can do something similar or just very much the same for queries. So here I have a handle /hello, but I want your first name and your last name. So that's being parsed again by Ambiorix as part of the queries, and I get them here and allows me to return then, hi John Kuhn, here if you visit this URL with this query. So these are two very powerful things that we have in there. This only covers really the basics. There's tons of stuff that I've added. Too much to talk about. So I want to talk about a bit about the ecosystem that's around it, and also because it allows me to talk a bit about what I think, some learnings that can be interesting for the community. So generally, the way you would extend such web framework, and that's true of Express.js. I'm pretty sure it's true of frameworks like Django or the standard library in Go, is with what we call middleware. So where we have those handlers that receive a request and send back a response, something very similar, except they don't necessarily send back a response. They can be used to pre-process things or post-process things to make your life easier. And this is a list of them that I have written myself. So we have a logger, a minifier, so you can optimize the size of the HTML you send back, manage sessions, the security of how to secure your cookies or general security, Prometheus metrics, caching favicon, plenty of other stuff that you can do. And I have some documentation online on how you can build those yourself. Then as part of this ecosystem, as I call it at least, there is a load balancer. So vertical one, as in it's going to run on a single machine. I haven't reinvented Kubernetes here, of course, but it can help you, I think, make the most of whatever machine or pod or whatever it is that you're using. So it's written in Go. You can install it like this, or you download one of the binaries. You likely want Linux. And essentially, what it's going to do is run your application X number of times. You define that in the background, and when a user visits your app, it's being redirected to one of these apps running in the background. And what that means is that you reduce the number of users per hour processes, and overall you improve the performances of the application. Then we have a generator, which is essentially use this create package function, which I use a lot. but for Ambiorix, so you can set up a nice project easily with a single line. And then we have a command line interface on top of it that's written in JavaScript, so you can install it with npm. Allows you to again create a package easily, or to start your server, to stop it, these sort of things, so you can interact with all of that from the command line. But here's, I think, the more interesting point of this talk. So it's not just about me plugging my stuff. If I can help the community with some things, it's probably this. So why did I take an inspiration from a JavaScript framework? Well, first is simply because people like it. It's a very popular, well-tested framework that is Express.js, that has a very friendly API. And though I have only built a handful of applications in that framework, I really just enjoyed how it worked. And I thought something like this was missing in R. And as I've written in small there at the bottom of the slide, it was also essentially for me to learn more about web frameworks. I do a lot of work every day building web applications, yet I had no understanding of how they worked. That was 3 years ago now. And I wanted to base myself on something. So I have a reference point to work with. But here is the thing that really surprised me, is the unexpected benefit from essentially copying this API, this user-exposed API of Express.js. So when I did that, I accidentally copied some of the internals, of course, because they're tied. And so the internals of Ambiorix are in places similar to Express.js. And that's what allowed me to have all this giant list of middlewares. It was surprisingly little work to do. I was very impressed when I saw that most of those middleware that the list of middleware that I have shown you before are inspired by middleware from Express.js. And most of them are surprisingly simple, used by hundreds of thousands of apps, most likely apps you have visited, but most of them are 100 to 500 lines of code, some of them under 50 lines of code. I think very simple stuff that, since my architecture, if you like, was resembling that of Express.js, was easy for me to port. And then going through the code and being able to translate stuff into R, essentially. So if I have an example, I'm going to leave the full screen, and it's rrr.is. The code is open source, everything's open source, and it's a URL shortener that is built with Ambiorix, and that works, and that is deployed with the load balancer that I mentioned. Just checking the time, just a minute. So if I log in, I can shorten URLs and then track the clicks. So if I click here, I can see the number of clicks on rrr.is/cool. I can see, I don't know how many we had, 4 clicks here. If I click on it, you see I've been redirected to the home page. It's very fast, but normally I think we're at 4. We should be, yes, we're at 5. If I click this link /go, it redirects me to google.com. I think it's fast enough. And the platform is very simple. We can shorten more links, go back to the home page, etc. Uses cookies to sign you in. So if I click start, I'm back in. So we can do all of these kind of, I don't know, things that I feel were, at least in my mind, lacking in R, are perfectly doable, at least with Ambiorix. And that's about it for me. Thank you very much. I'm all ears if you have questions. Thank you very much.
Hey, thanks, John. This was pretty interesting. So I'm definitely going to go dig in myself to learn a little more. So before I hand it over to Casper, there is a questions coming for you, John. Does
Sure.
Ambiorix also support Jinja templates?
Jinja templates. That rings a bell, but I'm afraid I can't tell you exactly what it is. So I can't answer your question. That probably means no. If I'm not sure what it is, it probably means it's not supported.
Okay.
Well, I'll look into it. It looks interesting.
All right. So Casper, you think is all sorted out, your technical difficulties?
I hope so. Can you hear me?
Oh, yeah. Oh, perfect. We could hear you now. Yep. Go ahead and take it away
Cool.
if you want to share your screen.
Cool. screen now, won't be a sec.
Yep, we see your screen.
Here we go, so you can see my screen.
Yeah, and we got to hear you too.
So this talk is on Detour, which is an R package that I've created as my master's project at the University of Auckland. So the package Detour provides interactive and performant tour visuals. So before I can really talk about that, I just need to give a quick background on tours in general, just to explain what they are. So a tour is essentially you take a sequence of data that's of more than 2 or 3 dimensions. Take a sequence of projections and then you display them as a smooth animation. You create them in 2 steps. So one is you create the tour sequence of projection matrices, selecting a series of projections and then interpolating between them so that the animation is smooth. And then you display your data, your projected data as an animation as the display method. So an example I have here, this is a GIF. And it's using the Palmer Penguins dataset, so just a simple, small dataset that we can use. So that's the idea behind tours. So what's the motivation for creating a new package for doing this data visualization if that tour package already exists? So there are some limitations with some of the existing tour software in R. For example, if I want to include a tour in these slides, this is a GIF. So one of the main purposes of a tour is so that you can do kind of exploratory data analysis. You can identify outliers and see if there are kind of natural clusters forming in your data. But because there's no interactivity, it's kind of hard to identify which points are which makes that a bit difficult. The second is performance. So if you have a very large data set, it can be hard to get a decent frame rate. And so the animation that you get ends up being not as smooth, perhaps as we would like. A quick disclaimer here as well, because this talk has a few animations in it. I'm not sure how well they appear over video conferencing. So I would encourage you at the end, I've got a link to the package itself. So I'd encourage you to try it out. And the last one is portability. So the first time we went to use the tour package in R, idea is VS Code. So took some sample code, ran it in VS Code, didn't work. Tried this is what came out because it's generating kind of a sequence of images. It doesn't really work if you're using, say, a Markdown notebook, for instance. So how do we get around these limitations? We take a detour into web technology. So specifically using the HTML widgets package, we generate visuals using that as opposed to using the R graphics device or using GIF images. So this is Detour. This is the same Palmer Penguins dataset. An HTML widget. Obviously, I can pause the animation. There's some interactivity here. Specifically, though, with those 3 before, so the interactivity, portability, and performance. I'll just go through each of those and kind of how we address them and what that looks like. So first is interactivity. So with the Detour package, we have over control, so we can scroll to zoom, we can click and drag, a few 3D visuals, selection brushing. So we want to change the color of points or select points. We can highlight them, change the color of them, and continue with the animation. So it's quite interactive in that way. We've got a timeline down the bottom, so we can play, pause, restart. We can scrub through the tour, so we can go through and a projection that looks good to us. And then down the bottom here, we also have each of these little dots represents one of the basis frames. So like I mentioned, we generate a sequence of projections and then we interpolate between them. So these are each of the projections that we're interpolating between. And for each of them, we can click on it and go straight to that basis. For portability, because we're using HTML widgets, you can display the visuals anywhere that you can display JavaScript or HTML, so any browser. RStudio, which is pretty much just a browser. VS Code, which under the hood uses Electron, which is Chrome, so it works there too. You can embed the visuals in, if you have a HTML, you can embed them there, Shiny, and then also Sharingan, which is the tool that I've used to create these slides. You can embed them in there pretty easily. And performance. So this one is one where I'm not sure how well it's going to work over a video conference, but on my screen at least, using this data set here, which is 10,000 data points, you can get a pretty smooth animation out of it. Just a quick description of this data set. So what this data set is taken the MNIST set and created a set of embeddings of the data set. So it's an 8-dimensional presentation of those. And because those embeddings are L2 normalized, if you take that data in that 8-dimensional space, it all sits on the surface of a ball. And so it's just this big hollow ball with points all around the outside. That'll be more important a bit later. So Detour also supports linked selection and brushing, so it allows for essentially Shiny-like interactions, but without needing the Shiny package at all. So for instance, if I can select points in this Detour visual and have the same point selected in a corresponding Plotly visual. And likewise, I can select points in the Plotly visual and have them highlighted in this Detour visual. Quite a few packages that are compatible with Crosstalk. For plots, you can use obviously Plotly, like what I showed before. If you have geospatial data, Leaflet can work as well. DT and React Table if you have tabular data, or if you want to display a table. Sorry, and then also HighCharter, which is another plotting package. So now we create these visuals, so what the user API looks like in R. Detour is now on CRAN as of a couple of days ago, so you can just install it using install.packages Detour. You can also install the development version using the remotes package. And I said this repository /Detour. So to instantiate the tour, it's kind of a 3-step process to build the tour visual. The first thing you specify is the data using this Detour function. So here itself, in this case it's penguins, and then we specify the aesthetics. So it's kind of similar to ggplot2 in terms of how the aesthetics are used. This first one, the projection, that's the numeric data that we're actually using to project from high to low dimensionality. And the visuals that we have currently in the Detour package support a color aesthetic and then also a label aesthetic as well. Oops. So the output of this is empty, and the reason why is that we haven't defined the tour path yet. So in order to define the tour path, we then just take the output from that and we pipe it into this tour path function. And then we specify the type of tour that we want to use. So all of the visuals in these slides use the grand tour, which essentially just selects a series of random projections of your data and then interpolates between those. But there are quite a few other ones that you can choose as well. Like these functions come straight from the tour package in R, so any that are available in that package can be used with Detour as well. And the result of that is essentially a data frame where we have this is new basis columns that indicates whether it's a new basis or if it's one of the interpolated projection matrices. And then the second column is a list of the projection matrices that we have. And then to actually show the visual, we just take the output from that toolpath function, we pipe it into the show scatter or any show function that we want, and then that it will then output the HTML widget. And so this is the result. Like I mentioned, it's a three-step process. So you start with your data, then specify the toolpath, and then the display method. So in the detour package, it looks like this, starting with the detour function, then the toolpath function, and then any of the show functions. Now I'll put a star here because there are a few available, which I will quickly go through now. So the first is the one that we've seen so far is the show scatter function, which is essentially an XY scatter plot in either 2 dimensions. It also supports drawing edges. So in this case, a 4-dimensional cube, and we can draw the edges between the lines in order to display that. And then likewise, 3-dimensional version of that scatter plot. So each of these have both a 2D and 3D version. This is a PDF sense dataset, which is a physics dataset that has, I think, 56 dimensional input. Particular dataset because you have because the input data is really high dimensional and then you're projecting down to low dimensions, the points tend to kind of crowd towards the center of the visual. So even if you zoom in quite far, there's still quite a lot going on here and you can't really see a lot of the points in the middle because they're obscured by other points, which is where this Sage display method comes in. So what this does is when you project from high dimensions down to low dimensions, it will then apply a radial transformation. And the reason for doing that is just so that the given radius in the original data set is projected down to a lower dimension. And so in the case of this MNIST embeddings data set, like I mentioned, the ball. And so in this visual, that ball structure is much more apparent. So you can see, obviously, that it is very circular. And then for that same PDF sense data set that I showed before, this is the 3-dimensional Sage visualization. All of the points have been scaled outwards from the origin. Cool. And the next display method that we have is the slice display. So what this does is when you have a projection plane, any points that are really close to the projection plane are highlighted and any that are further away are faded out. And so you end up with sort of a cross section of your data. This is a Roman surface and displayed using the slice tool. And like all of these so far, it also extends to 3 dimensions. So this is what a 3-dimensional slice looks like. And again, with this data set, like I mentioned, it's kind of this hollow ball. And when you use the slice tool, the only points sort of around the edges of it are highlighted. And so the benefit of this visual is that it's really good at visualizing hollow in those high-dimensional data sets. Cool. So a couple of quick notes on performance. I'll go through this fairly quickly. So one of the main goals with Detour was to improve performance, so getting smooth animations for large data sets. One of the ways that we achieve that is because we're using HTML widgets, we're using JavaScript, and JavaScript is generally pretty fast. Browsers are very highly optimized nowadays. And so we get a lot of performance for free pretty much. But there are a couple of areas where that's not really the case. So if you have a look at this, this is just kind of a rough data flow, what happens in the tour package. So instantiating the tour, generating tour path, creating the widget, and then everything else happens on the right-hand side here in JavaScript. When you're displaying an animation, we're constantly calculating our projected data, which is this y is equal to our data matrix x times a, and then rendering the points. And these are kind of two bottlenecks because we're doing them 30 times a second. Any performance issues in linear algebra operations or rendering have a really big effect. So for matrix operations, in order to get around the fact that JavaScript is single-threaded, we use the TensorFlow.js library, and behind the scenes it uses WebAssembly in order to allow for parallelism, and that parallelism is achieved using SIMD, which is for data, and threads. Then for rendering, originally when developing Detour, we're looking at using the D3.js library, but an issue with that is that it uses SVG primarily under the hood. And when you get to a large number of data points around, it really starts to. So instead, we use element with a WebGL rendering context, and that means that the rendering on the GPU, and you get quite a big performance benefit by doing that. And this is implemented with the 3JS JavaScript library. If you're familiar with the TensorBoard embedding visualizer, same library that powers that. So there may be some similar feel of that. So with Detour, we've got some cool visuals in there at the moment, but there's plenty more that we can do. So contributions to the package are certainly welcome. One thing that we need is more visuals. So at the moment, we've got XY scatter plots. So we can display 2D and 3D data. For one-dimensional data, density plots or histograms could be quite useful. And for displaying data that's more than 3 dimensions using parallel coordinates plot or Andrews plot, whoops, would be quite handy. More features, so ledger, being able to change the symbols that are displayed for points. Don't have yet either. And with performance, there's always room to improve. So one thing about the Sage tool that I mentioned before is that the performance of that isn't quite as good as some of the other visuals. So maybe it'll be worth writing some custom low-level code for that. And with TensorFlow as well, there are multiple different backends available. So perhaps trying out the WebGL backend for TensorFlow would be helpful as well.
Hey, Casper.
One thing is, though, if you do,
probably we should wrap up your session now so that Augustine gets the time to wrap up our session. Anything else you want to cover quickly in 10 seconds or 15 seconds before we hand over to Augustine?
Yep. So if you do want to contribute to the package, just have to include the in your pull request. So that's all. Slides are available here at this GitHub repo Casper/paper detour, and the source code or the package website is
Excellent. So thank you so much, Casper. I know that you had the technical difficulties. There were some time lost for your side, but this is very exciting and very interesting. So with that, our last speaker, Augustine, please take it away.
Yeah, I think if you can stop sharing. There. Thank you. Hello, everybody. So I think Casper talk falls very well, and because I will be covering a few of the things that he highlighted. So my goal here is to describe a few techniques we have used to create interactive dashboards without Shiny. Full screen. So what we're going to do today is focus mostly on three things. The first one is tricks that I have used to create interactivity without Shiny. We are going to present slightly techniques to create the dashboards. And finally, I'm going to demonstrate some examples from our own work. First of all, jumping right in, let's talk about interactivity. One thing that we have used in order to create interactivity is a connection between crosstalk, I was described a little bit earlier, and Plotly. And both are very powerful tools. Such an interaction of these two tools allow you to navigate, to have a drop down and select. For this example in which I'm showing recruitment to a clinical trial with mothers and childs and babies, you can select which side you want to focus. And because you are using Shiny, because you are using Plotly here, you get a little bit of interactivity in the figure itself. And you can select select which side you want to focus on. That is done through the shared data from Crosstalk, and then a filter gets built and the figure gets generated. I use ggplot, and then Plotly has a very nice tool to turn those ggplot figures into Plotly. The other tool that we have used a lot in our work is eCharts, and I think the developer is here. So John, fantastic package, thank you for it. And the way we have used it is by connecting charts through, by connecting charts. eCharts for R does not allows crosstalk, but I think you can use this connector function to connect the charts together and have little widgets interact between the charts. This is the same data I present earlier, but now I'm having a timeline here. So this timeline, you can navigate through this timeline and you will go through different sites for each of it. And it's changing both charts simultaneously, the mothers and the babies. You can play it also if you want. And here for the data zoom, you can also, the two charts are connected. So once you select, you can zoom in simultaneously. So I think this is a fantastic tool to connect many charts together and use interactivity. It is done by you create individual charts, but then you can connect the charts with eConnect, and then you will arrange the charts together. The code is all available in a GitHub account so that you can go and reproduce if you need it. I got this idea actually from Jelle that has a fantastic example in which he creates pretty much a whole dashboard based solely on eCharts for R. And you can go and see it. The code is not available, but just knowing that it's created with this eConnect, it will let you create your own interactions for your own displays. The other package that we have used a lot and is Trelliscope.js. This is a port from a JavaScript into R, and it allows a interaction through um, a, a frame of work. So here we have the same data. I'm just going to enlarge it so you can do. And first of all, you can navigate through through the options up here. You can change the layout. In this case, is 1 by 1, but I can add another row if I want. So here is, I have added another row. I can add labels to the data. So if you have metadata, here is the total number of babies at the end of the recruitment period. I can add that. Those labels get at the bottom. And then you can filter and sort differently. So now we sort by site name. I can take that out and I can sort by that metadata, by the babies, either in ascending or descending order. So this gives you, and it's very powerful in the sense it's very fast. So here what I have embedded is I have embedded Plotly into Trelliscope, and then you can get a lot of navigation tricks this way. The code is described here, in which I tend to do this a lot. I do a nested data set. So I create, I nest my data by site, and then I create the plots. And because the data set is nested, it's created a plots for each line of code. And then the Trelliscope is easily extended. A Trelliscope plays extremely nice with ggplot. As a matter of fact, there is a facet Trelliscope that you can simply add, and you will have, without much effort, your Trelliscope available. And this fits very well into presentations or dashboards. We also have used React tables, and oftentimes React tables, you want to also use this friendly package React Table Formatter that has a lot of very nice add-on to the package. And the way we have used React tables is by embedding the figures within the table. So in this example, again, the same data, we can just click in here and we obtain the figures for each site. And if you want to look for a site in particular, you can say, okay, let's go to site 7, and then you can choose that way. You can sort them by this way and then focus on those that are recurring the most or those that are recurring the least. And the way it's done is you just create the figures and then you embed it in a detail tab in React table. Leaflet is also something that we have used somehow, and here you can, through Crosstalk and through other packages that interact well with Crosstalk. Here I have given an example with DT, ggplotly, and Leaflet, and you can quickly navigate the data or search your data and focus on some individual points. So everything is interacting, and all this is being done through the, I will say, the power of a Crosstalk and of other packages that work with Crosstalk. So the last one, which is just my, it's a nifty program that it hasn't been updated in a lot of years, but it works just very well, is you create the figures your own, and then the BS selector R allows you to actually just create a tag, a tab, a drop down, so that it just call that a figure. So this is, if you will, you do a do loop, you do all your figures, and then the drop down does the selection. And it's actually quite easy to do, because once you create your figures, you do the names of the figures, you name your figures, and then you pass it to the VS selector, and things are matched. I'm sure for people that are very good at HTML, this may be easier, but this is just was a good time savior for us. Finally, let's talk about dashboards. So for dashboards, we use the Flex dashboard package, and it is a markdown document with a very specific layout. So what I have done for saving a little bit of time, I can create it here, a cheat sheet that you can navigate with different layouts. For example, this first page has a layout where you have side panels for selectors if you want. Then this a layout with one large figure and two smaller ones. And then a layout that I have used a lot in my work is the frames, where you create individual frames and you navigate, or you let the reader navigate this way through your dashboard or presentation. So now some examples. These are examples that I have developed for the Wonderful Wednesday. That is a group of people that meet to try to develop newer visualizations. And in this one, for example, I have built results tables based on React tables. If you want this, sometimes in statistics they are called forest plots. So I have built a forest plot in React tables. You can search for things in React tables if this list is long, and then you can look at subdata. Here is the cumulative incidence for each variable, and this is built directly in a dashboard. This dashboard have different tabs. For example, I have created a table 1 here, in which we display the raw data by also again a judicious use of React tables with a plotly. So you can look a little bit at the distributions, or you can sort by missing data before you are getting started with your analysis. And then sometimes I like to embed maybe the actual manuscripts in a PDF, so everything is self-contained. But in this case, there is no use of Shiny. The interaction is all done by these libraries that have good JavaScript or crosstalk. The next example is another visualization that I have created for a continuous glucose monitoring visualization. In this one, I have used a Trelliscope. There is like 596 patients. So if you have an individual patient that you want to look, or you want to sort by some metadata, for example, some variability of these measurements, you can do it easily with the use of Trelliscope. In this case, sometimes I have done some modeling approaches to this data, and this modeling approach use packages that are not crosstalk friendly. This particular package is recursive partitioning. So in order to do this, I have created in a do loop all the modeling results, and then with this VS selector R, you can choose which statistic you want to focus in. This one is, again, the use of a Trelliscope to look at individual patients. And here what you have is the presentation with tiles. So you can get to see a little bit, walk the reader from very individual data, such as at the patient level data, and then you move to a group level data. So you are presenting the data in a very orderly way by allowing flex dashboard styles. And finally, I have two examples of our own clinical trials report. This one that I have here is a SARS studies. The data has been anonymized, obviously, but we have recruitment gauges or percents displays for the viewers. Some of these are static, some of these are interaction between crosstalk and Plotly. And then you have here your React table. In this case, the randomization data is done through through a spike histogram package. But nice thing about this is you can sort or you can focus on a particular site if that's what your intent is. And the last example I have is something we use to check on forms completion. This is all built within a React table, and you can navigate here. So with you, these are all the sites, and there is completely missing unexpected forms that are not yet filled. But if you want to focus on missed forms, you can just simply tag along here, and the HTML code, the React table code is updating the table accordingly. And then within there, you can focus on individual forms. These ones for these particular sites, the enrollment forms that have more than 70, 80% missing are all at enrollment, and they are all coming from the diet. And you can check which anonymized participants are missing that form. So it allows you to focus. And if it is oftentimes when you do this, you are not concerned about the other people's sites, you are concerned about your own site. So you can pick your own site and just focus on that. So that was my last example. I put the slides are available in GitHub. All the code is available in GitHub so that you can reproduce or take some of these ideas for your own work. Thank you.
Thank you, Augustine. That was very wonderful. So we have 53 seconds left as this clock that's showing up on this platform. I do not have any other questions come through to the Q&A. And we are also pretty close to be our time. So with that, let me take the opportunity to thank all of you. Our four speakers, Matthias, Casper, John, and Augustine. Thank you so much. This was a wonderful, very insightful, very interesting. I'm sure the audience will find good benefits and learning out of this and go back and try or contact you as they have more questions. So with that, I also like to take the opportunity to thank all our attendees taking the time wherever you have joined from this world. So thank you so much for your time. So with that, let me close the sessions. Thanks, everybody. It was good having you guys.
Thank you, everyone.
And thank you
Bye-bye.
to you for hosting. Appreciate it.
Bye-bye.
Bye.